Так, ну что ж, давайте продолжать тогда и, соответственно...
So, we can continue. Our next presenter is Oleg Pravdin. He will speak about smooth migration of highloaded project. Hello, thank you for coming here to discuss this interesting issue, that is transition of a working backend to new Rails. My name is Oleg Pravdin. I'm Technical Director of Lingual Layer Company. This is an online service for studying English. It is present not only in Russia but in 20 other countries of the world. Have you ever heard about it? Have you used it? Yes, that's great. So, I think that in that case it will be easier for me to explain what this service is and what difficulties we had and how we settled them. So, over 10 years, this service has grown up to 20 million users. That's quite a lot. But in the middle of 2017, it was decided to launch this difficult process of migration. So it was decided to transfer whole backend to a new technology, and to make such a decision for any company it's necessary to answer the main question: why? Why are we doing that? Why are we doing this difficult adventure? It's real adventure actually. So in our case, we were guided by the following factors. So what are the goals of migration? The first one, we wanted to decrease the time frames of the main features of product by 5 and more times to speed up the development of new functions. The second issue, the staffing of developers was bloated. We wanted to make them redundant, and also we received very large bills from Amazon for infrastructure. It was too expensive. The access to database was possible through many external services, and it resulted in many problems and unnecessary risks. And over 10 years, we didn't manage to document the work of backend completely, so it was a real black box. We didn't know what was going on inside. Why did we make these conclusions? Why did we set these tasks? First of all, we need to look at the status of backend. What did I see when I got familiarized with it for the first time? I saw a monolith, 1 billion strings of code. It is normal, actually, for considering the time. It was maintained by 8 developers and 2 admins. So, to implement some small function, it was necessary to spend 1 or 2 months because we needed to test everything and the development was very slow. We received very high bills from Amazon. As I said, for 10,000 active users, the costs from infrastructure were above $1,000 per year. It is too much. The access to the base was provided from anything, so those that wrote code on PHP, they could do select and work with the base. The base had 400 tables, and for them to function normally, sharding on MySQL was done, so it was 100,000 tables with data on users. 100,000 tables. I think that not many people can work with this amount of information normally. Besides, there was no real description of this product. To change all of this, we decided to change the philosophy of backend as a whole. So, what is migration as I see it? Migration is the change of back-end philosophy. It's not just that it should be 10%, 20% more efficient, it should be much more efficient. And how did we want to achieve it? First of all, we transferred all business logic from monolith to database. Thank God Postgres lets us do that. So, we simplified the process of development, and besides, the size of program code necessary for the implementation of the functions shrinked by 20 times, and we started using not only SQL structure but also NoSQL structure. So as I understand it, actually in Postgres the use of such fields as JSONB, and that is also important, it gives us flexibility, and on the other hand, it doesn't affect performance. This is a very important point. And besides, we closed accesses to database from various microservices. So this was a single point that addressed the base, the single service that was proxy service, and it didn't address the base with select or insert. It called the stored procedures. It didn't do anything else. Now let's look at the picture. The architecture that we had before migration. You can see that various queries are received from front. Monolith is processing it, and it actually works with many SQL queries. After that, raw data are received, processed, and as a result, it provides responses in the form of JSONs. So this is a huge structure that was not regulated properly. And in this structure, we substituted three main components. First of all, we substituted MySQL by Postgres and transferred all business logic to it. So all calculation and JSON preparation was done in Postgres. After that, we took these million strings of code and threw them away. We started using proxy service that put the queries to the necessary database. Some of them went to master, the others went to slave. As a result, it got JSON and it returned it to the front. So this is step 3. We changed the model of interaction between service layer and database, so a service is called and a ready JSON is received, and without additionally processing it goes to the front. So this structure became much simpler and much more effective in terms of performance. Now let's look at its implementation step by step. Data processing in one place, that is logical. Postgres was devised for it. It works with data much better than any other language such as PHP or others. PHP can cope with this task several dozens times better. So, any storage. For the storage to be universal and flexible, we were to provide convenient parameters for entry and exit. We have JSON product that can be extended in all directions in the depth and in the width. So, it has more attributes, and every storage was about one parameter for entry and one parameter for exit. One parameter for input, one parameter for output, and it was difficult for us to achieve the situation when most parameters are not obligatory, because in that case the storages would be more flexible. For example, you can get various set of parameters, filters, or some other conditions, and we do not want to write a specific storage for every case. That's why it's better to create a storage that maintains non-obligatory parameters. In that case, you will cover a lot of cases with small amount of code, and this solution will be flexible because, for example, tomorrow product managers want to add something else, and you would not need to put a new storage. You will add 2 new non-obligatory attributes, so the attribute works with old calls in a good way, for example, one old version of application calls it, and with the new forms from the web. So this is the issue of version. I do not need to maintain several versions of storages to solve one and the same task. It can be resolved in one place. Next point, what is a storage? Having written more than 100 various storages and having analyzed what we have as a result, on the whole I can say that storages are a huge SQL query. So it starts from maintaining common table expression. I prepare one table, second one, the third one. After that, I gather these tables together. They are quite small in the memory. After that, I take the necessary attributes from JSON-B, I pack them in the response that is needed for the front, and I return it through proxy service to the front. And all the storages that we had are represented in this format, so the code is quite concise and it can be developed in a very fast manner. And besides, we switch on data for analytics at once. That is important because today you did good maintenance of front. After that, product managers came to you and said that they want to have a lot of analytics. And for us, not to do any double work, the data that is needed for several analytics can be included into JSON response, because actually these data were already received. It means that you would avoid double work. You will not need to process raw data. So we can pack it all in one thing. And now let's look at a specific example. You can enter the website. This is actually the page of English learning course. So some pages, here you can see some pictures and text, but actually to prepare this kind of a page, we need to fulfill more than 10 criteria in terms of content and user. For example, the user studies English from various languages, so we need to know the language of the user, and we need to know what description, in what language we should provide the description, and there are various courses we need to take it into account. There are free courses and paid courses, so we need to see the parameters. The prices of courses differ, and these prices depend on the offers provided by product managers, because they can actually have a discount for a specific course. We should take it into account. Some courses were already bought by the user and others were not bought, so some of them are available and the others actually have price on them. The user can activate promo code. In that case, the price will be different for this user, and for another user it will be actually different. At the basis of marketing, you can see a line here. It means that the user had already started this course. They have passed several lessons. So we are showing the progress on this course. We need to see how many lessons this user has passed and show it on the screen. All of this should be done within one storage. We do not want front to make 10 queries. Give me this data and this data by the use of one query, one response. That's it. Because front should work with the data ready for representation. That's it. Within one query, only one query. It shouldn't have many queries. So, what did we have in the past? We took PHP, wrote code, we needed some data, and SQL query was written. So these data were received and processed, and after that another SQL query was needed, and as a result there were 12 SQL queries while this page was being prepared. 10,000 strings of code, 12 queries, 15 days of development, and about 15 days for debugging, and the execution took about 600 milliseconds. This is X5 large class. This is something that we had before. This is a classical solution. And what did we have after migration? We use PGSQL only. We do not need to use other languages. We have 300 strings of code. One select. It is large, but it is one. It is much easier to see and analyze 300 strings than 10,000 strings. Only one query. The development took us 2 days, probably even less. Actually, this time includes optimization and debugging, and the execution time is 20 milliseconds. So the result actually is similar, but the cost of development, maintaining, and infrastructure is very different, but the result is the same. This is the specific example, and I can say that the more difficult front is, the more elements it has, the more significant the difference will be. So if this page is quite simple actually, but if it is more complicated, it will be not even 10 times, it will be actually several dozen times different. So this is the issue of optimization of development time and performance.
So what should we do with these numbers of tables, and how to implement new desires from product managers without creating new structures, without doing a lot of factoring, etc. So we have 400 tables. We packed them into 8 tables with JSON-B fields. Let me show you one of those tables for you to see how we did it. So in one table we included a lot of entities. What do I understand by this? Let's see step by step. There will be 6 columns. So the first column is user ID, which is natural. This field must be selected. Field 2 is entity. What is an entity? For instance, the user registration number, payments made, subscriptions, activated services, trainings that the user has taken. There can be hundreds of entities, and each entity has an ID. For instance, 200 registrations through email. Each entity has a key. So those 3 fields are unique for each string, each record. So to make it fast, I added 2 fields, their own number fields, date, time, and there is one more field, big int, and I insert different data as bit masks. What do I mean by this? For instance, payments. In payments, we may have important attributes. Through which provider did I pay? Through which platform did I pay? What was the status of the payment? And each of those values is small in terms of variances. So there is no need to add int or small int. You can allocate 2 or 4 bits. So in one big int, I can insert 10 to 15 different values, parameters for further filtration. We'll see how it works. So for different entities, the selection of those bits is different. For payments, there is one set, for training another set, and the final field is JSON-B. Why do we not need to make fetching through filtration for further displaying at the front? So here we have a freehand. We can do as much as we want. In addition to those 6 fields, I added indexes. One is primary key, and the second index is number of fields, so that I can select all the payments in the last month. So the fields include indexes. Indexes include fields. Index 3 is an auxiliary, but sometimes it is necessary. For instance, to see active subscriptions or subscriptions that need to be activated today. These are linked to entities. For instance, today we need to activate 100 subscriptions. And then we'll launch further activation. On the basis of this table, what will select look like? Select in storage. So the first step is the most important one. Out of several tables with billions of records, we need to select 100 records. It should be very quickly, in parts of milliseconds. For that, we need to consider the query so that the first selects after with go to index-only scan. This is a great feature of Postgres. Maybe some other databases have similar things, but this feature works absolutely great. I was shocked when I saw it first. So if you optimize the query so that you see those 3 magical words in your explain analyze, don't worry about performance. No matter how many records you have, no matter whether you will add another million users, your query will work fast. Out of 1 billion records, we get 100. So we did the most important part in terms of the query optimization. Then we can do anything we want with those strings. JSON may be slow, people say, but let's take a simple query. I have a table with 1 million records. With JSON, JSON has 10 attributes each. So I select an attribute within a JSON, for instance, x5 large. So how much will it take to process this query? Million records, JSON-B, no indexes, just search through it. So how long it may take? Do you have an idea? 2 to 3 seconds in reality. So give it a try. JSON-B works fantastically fast. If you have 100 records, any operations with JSONs will take like splits of a millisecond. So do not be afraid of this field. This field does not make the query 100 times slower, not at all. So we have selected those records. We collected JSON. Now we're working with a small amount of data. We packet it, send it to the front end. This is a regular storage in terms of size, 20 or 200, 300 strings of code. Let us summarize the benefits that we get from this implementation. Well, first of all, the structure has become stable. I should say that within 1 year I didn't add any field. Although we added a couple of entities, we did not update the structures. I did it last time in the summer last year. Flexibility, so we can introduce new functionality without redoing the system architecture. Dates, writing 3 strings of code is faster. Writing 3 strings of code is faster than 1,000 strings of code. High quality, high performance, so we can achieve a 100 times increase in performance. Load balancing. Balancing can be set in config master, slave, master 2, slave. You can even do multi-master. We can discuss this. Available data for analytics. Data is processed and then the analytical systems will display them for the products. No foreign commands, no foreign SQL commands. So we only deal with the storage. So the user cannot do select or update. It has the right only for the appropriate things. Administration, 8 tables and 2 servers. It's easier than administering 400 tables and a huge number of servers. We do not have an administrator on the payroll. We support 24/7, and if there is a case, we get outsource support, and we do not need any more than that. We also have back-end manuals, and they have become very compact. I've shown you 10 benefits, and more benefits do not fit on this page, although there are many more benefits, maybe twice as much. So what did we get? So new code in the back end. The old code is in the museum of the company. Let it reside there. We haven't changed the front, so those JSONs that were sent were sent. So for the front, nothing has changed. The data structure has become simpler, much simpler, but one problem remained. 20 million users are in the old SQL structure. How can we get them in the new database? The idea was to stop the system for several hours and move them to the new format. We tested with several users, 1 second per user, but collect everything in 8 tables, repack, so 1 second is normal. But this is the case where if we multiply 1 second per 20 million, we'll get 8 months. That means we'll have to stop the project for 8 months, which is not a good option. So we decided to use hot data transfer to the new structure. If necessary, the code that we used for it, I can share it with you. So how did it happen? Overnight, we stopped the system for about 20 minutes and migrated the authorization data, the login, the passcode, and the user ID. 3 columns, nothing else. So we had them, then we turned the system on again. So the users start entering the website, they authorize themselves. And also we had to work on the front end a little bit. We showed a short welcome to the users so that we have time to move the data from MySQL to the new back end. This was the only development done on the front end. So when the user finishes reading the welcome, the front end becomes getting data from the appropriate places and in the new format. So this is the general idea of how the migration took place. Point number 4 was important: how to organize this. I checked for the available solutions of the internet and I couldn't find the ready recipes, so here is our recipe. So the first step was we made the full copy of the tables from MySQL to Postgres. The same fields, the same sizes, so we migrated it. We got 400 tables. On Golang, we wrote a service which was connected to MySQL and Postgres, concurrent connection, and we wrote storage, which prepares a number of queries to MySQL and PG. Because the structures are fully identical, the set of data getting from MySQL can be inserted into Postgres. Field data indexes are the same. We didn't have to transform data a little bit. but it's a separate subject. What comes next? Golang service gets this set of queries, does select, inserts raw data into 4 tables of Postgres. To make it faster, we launched 8 streams to make it happen quicker. Then the data is in Postgres. It's easy to work with the data. So we wrote a storage procedure, and the data is repacked into the new database. So as I said, 8 streams, which made things faster. And with this background mode, we were able to move the data of the user to the new backend within a matter of 1 second. So this is an example of how we can migrate from an outside database to PG, and not only migrate but transform the old structure, because it would be ineffective to work with the old structure. Let me summarize this part. Remember the first slide? We used to have several months, and now it takes 5 to 10 days. We had 8 developers and administrators. Now we have 3. These are the costs. The cost of ownership 10 times smaller with the same servers. Security, we had foreign SQLs from hundreds of places. Today we only have storages and 1 point of calling from those storages. Documentation, now we have the structure and APIs all defined and described. We can work with it. Are you not too happy? Another 2 slides, and then we can discuss it. So takeaways. Takeaway number 1. Postgres SQL can be compared with Oracle in terms of capabilities. This is how PostgreSQL has grown to. This is a super achievement. At the same time, Postgres has remained independent. This is the most powerful independent system, which is very important. We'll see that. 99% of backend can be implemented under this model. Handle the load. Maybe Facebook size of projects may be different, but the rest of the projects can follow this approach. The structure can be very compact. We had 8 tables. In some you may get 5 or 15. We had 8. This can be made efficiently without growing to the hundreds of tables. A small number of tables provides great benefits in terms of the development process. Maybe not everyone has tried working with a small number of tables. Also, to write good backend, it's enough to be an expert in PGSQL. If you know it well, you will write backend without any issues. And this opens up a lot of opportunities for the PG community, because those experts who know PGSQL a lot, there are a few of them. Maybe 1 in 100 of experts in Golang is a PG expert. So those PG experts can make very good money on it. Moreover, PG community is self-regulating. Some writes a code, some tests a code. And here the model can be as follows. 1 expert can be responsible for several projects, and the second expert can control how things are going, how development is going, how code is developed. Code is compact, hundreds of strings of code. The same technology, PGSQL. PG community knows how to do this. People know how to control each other. On top of that, the first item is that even in small companies, the payback is within several months. Our payback period was short, and we got hundreds of thousands of US dollars per year of savings. So it is worthwhile trying. And you can pay good money to people who know how to do it. Very good. I mean it. It's not just above the market price. It's important to invite experts from the community to the projects. we had a project, monolith. It was stopped. Nobody wanted to deal with millions of strings of code. So the project was stopped. But in our case, you can just hire an expert, the one that you like, and be comfortable with him. Another interesting case, for instance, you launch interesting startups. They need backend for the startup. It may take you 2 or 3 days. So I was able to do a project like this during the weekend. This is quick. So I developed backend for a startup. So I suggest let's think about it and let's verify it on real projects. Thank you, and this is my contact information. I'm open to your questions now. Yes, thank you for your presentation. Did you bring the logic to the database? Do you cover the backend with some testing? And if yes, how you do it? Testing, yes, we covered with testing. We've prepared standard queries, took them from logs. We checked which type of queries we get from the front end. So our project was not from scratch. So we had some front end JSON queries. So we have collected 1,000 queries and took those queries and ran them across new procedures. So basically we expected the same answers. It is not difficult to compare two JSONs to make sure that the function is operable. Then we change something, then we restore the database, launch JSONs, and compare the answers. This is how we test. And the second question. So you decided to migrate active users first, so they enter the system and then they migrate. And what did you do with the users who did not use your service at the time of migration? So at night we migrated them from old to new. So the non-active users were migrated at night. And how long did it take? Months? No, more. We started in May and we finished in November. So the last user was migrated in November, so it took us 6 months to do this. What is the average JSON size that you have and that you store in your tables? It depends on the entity. The average, it's hard to say. We usually fit into 2 kilobytes. Something that does not start growing. So you don't get into TOS? No, on a very rare occasion. In JSON we keep materials, text materials, which users are trained with. They're broken into words or complex attributes. This is big, but it is not used for any complex selections. So this is an available JSON that can be given to someone. Even if JSON is big, it's not a problem. But most of them fit into those 2 kilobytes.
Okay, do you have other questions? Well, I have the following question regarding JSON validation. For example, if you had a crush on the front end and all the fields in JSON are empty, what do you do in this case? Well, if JSON is valid, it will parse, but otherwise the function will not be called. So there is validation on front, actually proxy. When proxy service calls the storage with embedded JSON, for example, some missing text, it will show you an arrow, the arrow of the base of the database that the JSON is invalid. This will be an arrow. And if JSON is valid but some attributes are absent, well, the storage should actually check the attributes before executing the code. It should check whether these attributes are present, such as user ID, for example. This is normal. And validation of the attributes themselves is implemented somehow. Brother cases then instead of figures, the user entered not a number, so we had this error, not a number. Well, yes, when you read user ID, you should make sure that this is a number, which is quite easy to do. So the type of data can be checked. Another question, the index of JSON, does it have a colon? No. Apart from one index, all indices are numerical B3. Only in one case, when raw materials by keywords are used a different index. So, the simpler it is, the more reliable it is. Try using only numerical B3 indices. And what is the total volume of tables? The total volume of the base is 400 gigabytes, together with the indices and data. Thank you. Thank you for a very interesting presentation. I actually share the philosophy of using storage procedures, and I would like to mention another important advantage of these procedures, that is the privilege of login. So, is logging on when a user addresses you, maybe not in continuous mode, but in some difficult cases. So, this procedure enables you to remember what the user had requested. How do you do that? Well, what about login? When proxy service received a response from JSON, it returns this response to the front, and this JSON input and output call storage on analytics server together with the data. And these data are recorded in the log. So proxy service knows that this is the query, this is the response. It calls the storage and it adds a new entry into the log. So we optimized it. Actually, at first it is assembled, and we have an array of 100 JSON queries and responses, and after that this array is transferred to this storage for it to be saved in the base. Every response is logged, and the time of every query implementation is logged as well. So this is the time. This is the time of the response. You can actually extract one time from the other time and add one more attribute, because the call point is single, and that's why the logic is quite simple. Thanks a lot for your presentation. How frequently are storages modified? How frequently do you rewrite them or modify them? And how do you deliver them to the base? So you have one basic master or you have distributed part. And how do you validate them in this case? This is a very good question. Actually, this method enables us to have quite non-standard model of deploying. We try deploying updates twice or 3 times a week. Why? Because it is easy, and within these 2 or 3 days between deployments, only 3 to 4 procedures will change. The code is very concise. After that, we take these 4 procedures that are on master right now, such as script for restore. So if ever anything goes wrong, we just deployed it. We assembled this script with 4 procedures, deployed it on master, and actually due to the streaming replication, it deployed it automatically and it was launched. So 1000 strings and the script updated 4 procedures. An important issue is that if it is done frequently, then the volume of these modifications is small. It's easy to control it, but if you actually change the hundreds procedures within a month and you didn't have a new release, well, it's better to avoid it. If it's possible to make releases frequently, it's better to do it so. Other questions? Hello, thank you for your presentation. I didn't really get it. You have 10 tables as a result, so the first base had 400 tables. They were transferred, and after that, all of them were somehow packed in 10 tables, and now 400 tables were removed. Yes, after the end of migration, we removed them. We don't need them. So 10 tables that suit any structure, not only Lingua but any structure. Well, not really. Of course, we prepared these tables for Lingua. What is the advantage of this model? For example, last week we needed to introduce A/B testing of products, so I just added another entity with description A/B test, and I said what A/B test is assigned for this user. I didn't create a new table, I just added one more string in the documents, and I prepared a storage that uses this data. So I don't need to use new updates, new structures. I didn't need to change anything in a serious manner, just to introduce new functions. This is the main advantage of this model. And yes, you should also remember that the number of indices is critical. So you should have 2 or 3 indices per table. You shouldn't have too many of them. Thank you. Hello, I have the following question regarding validation of JSON. 400 tables were packed in 10 tables. And what can we do about the entities that have external dependencies and external keys? I do not use that. We do not have triggers. We do not have external keys. Well, just imagine a table, I don't know, for payments, payment status, and all of these data should, well, they should be validated. Not to need A/B testing without JSON bracket that contradicts the register or something blocked or something. So the specificity of the project was that you didn't need it, or what did you do about it? Well, actually, when the data were transferred, for example, we take this table and it has payments only. So we do not need to have a separate table for it. We took this data, for example, 50 bills. And of course, we packed them into a table with JSON. And during that time, we checked every field for validity. I mean that during the time of front work, when you get some data, some external reference to a log that was removed, so its presence is ignored, but actually the value, no, actually it's sent by JSON. It says, this is JSON, this is the parameter that this user requires to get payments per month. So it's not like we get a reference from front to an external key. No, we get JSON. I mean, in the JSON itself, it's possible to see links to other entities. And these entities should be validated. You have a storage, you can process it. You realize that this is an entity, you can process it by the algorithm. I mean that you transferred all of that to the logic of storage. Yes, of course. It is possible. That is inside the storage. And the storage is responsible for the validity of this information and the place where it was recorded. It is inside the storage, I understand, but actually there is such a solution from out-of-box solution when the tables were divided, and it will check at the stage of insert that there are some conflicts or they are absent, and in your case everything is in JSON. No, in JSON we have data and the validity is inside the storage, so this is additional work at the level of storage, yes. But, it's quite reasonable. I mean that we can avoid some complicated issues such as external keys and triggers. And did you manage to live without it? Well, in a really great way. The simpler it is, actually, the better. I mean, have you had any problems? Well, I don't really remember having any problems. We managed to avoid problems. We forgot about some logic, about triggers, because actually triggers can result in a problem, but when there are no triggers, there are no problems. No keys, no problems. Okay, another question. How do you plan to scale? Scaling, well, I can tell you about the current numbers. Server master has 2 x large and slave is x large. About 5% are loaded. Even if we have 10 times more users, it will work normally. And in clouds, in Amazon, it's possible to go up easily. So according to our estimates, we can grow by 100 of times without changing the architecture. And if suddenly, well, I hope that the volume will grow a lot, we can create multi-master system. By the following model, the main load on data volume and processing is related to the users. Also, they have their vocabularies, their storage, so we can have 2 masters with a different set of users. So even users are in one of them and uneven are in the other one. So for example, checks the user ID and checks whether it is even or uneven, and we would have 2 masters that are not dependent on each other, and it will work. And if we grow 10 times more, we will do it by the last figure, for example, 10 masters. In this case, there are a lot of opportunities for scaling. This is our plan. Thank you. Thanks a lot for your presentation. And now we will have a 30-minute break. And the next session will start at 12:15. Yes, and I can talk to you if you're interested. I can answer your questions during the break.